Hello, my name is Scott Soboleski. I'm a principal consultant at Quaternion Risk Management, and I'd like to welcome you to the first in a series of introductory videos to the Open-Sourece Risk Engine. The purpose of today's webinar is to introduce you to Quaternion's open source derivatives trade representation standard called ORE XML. The ORE piece of that is an abbreviation for Open-Sourece Risk Engine, which is a collection of pricing and risk models that consumes the ORE XML trade standard as its primary input. And the XML piece of that stands for Extensible Markup Language, which is a machine-readable text format for data structures and web services. The ORE XML standard essentially comprises a hierarchy of nodes and subnodes to categorize and classify relevant trade details, which can then be easily consumed by the ORE pricing models. In general, the standard represents the majority of trade details that would generally be agreed between two counterparties in a standard OTC derivatives term sheet. So today we're going to walk through high-level aspects of ORE XML for non-technical users and attempt to make this machine-readable electronic format a bit easier for normal humans to read and understand. So for context, another popular open source trade standard is this FPML, or Financial Product Markup Language, is also based on an XML format. And for those of you previously familiar with FPML, I wanted to highlight a couple of key differences between ORE XML and FPML, and describe the reason why ORE XML exists as a separate trade standard in the first place. The first reason is that ORE XML is exclusively focused on the minimum trade economics required for pricing and risk management. So it's a bit slimmer than FPML, which also includes representation for things like business processes and workflows. And the second primary reason is that ORE XML also extends more heavily into the exotic derivative space to cover almost every OTC instrument that Quaternion has observed from our banking and hedge fund clients over the last 10 years. So everything we review today and more can be found at opensourcerisk.org/XML. And that opensourcerisk.org website contains information about the model coverage that we currently provide through the open source version of our software. It's primarily covering vanilla and mildly complex instruments across all asset classes. So this website here provides a sort of a good interactive feature if you're a first-time XML user to go and click through and find a specific trade type that you're interested in and actually view the format of that trade within the web interface here and see specific examples for various flavors of instruments that you're interested in. The exotic instrument coverage that I described earlier is primarily provided through our commercial software, ORE+. That plus sign distinguishes the open source from the commercial version of our software. And so for more information about coverage or XML representation for those complex OTC instruments, I'd encourage you to reach out to our Quaternion offices at info@quaternion.com. And lastly, before we dive into the ORE XML standard in detail, I wanted to point out a great XML editor or viewer in Notepad++. Especially for XML, it has great options for searching, collapsing and expanding various nodes, and color-specific identifying information to separate different types of information from each other. So it's open source, which means it's free. And its functionality goes way beyond regular Notepad or HTML browsers that would typically default if you were to double click for the first time on an XML file. So our agenda today is specified here on the far right. The first thing I want to do is walk through some common components that are reused across all XML, ORE XML trades. The first is portfolio and trade identifying information. The second category I want to walk through are sort of our most common trade types, so swaps, forwards, and options in the vanilla space. touch a bit on how those components can be combined to produce different types of instruments. For example, you could combine a couple legs from a swap trade with an option to produce things like an interest rate swaption or credit default swaption. We can also touch a bit on how the XML standard changes when we look at exotic instruments or structured products, although I'll probably defer most of that time to a separate exotic webinar that goes into some of those products in more detail later on. And then lastly, highlight a very important component, essentially the schedule data component of these trades, which is reused across almost every instrument type, and that's used to determine or tell the ORE pricing models how to build the payment schedules. And then lastly, we can review the allowable values for standard trade information. So how you would enter things like currencies or dates or floating rate indices or equity tickers, things like that, that have a restrictive formatting in most cases specific to the ORE XML. So the first thing I wanted to highlight, as I mentioned earlier, were just sort of the highest level nodes. So every ORE XML begins with a portfolio node, which allows you to describe multiple different trades within a single XML file. So in this case here, I've highlighted just a single trade within my portfolio. In this case, that trade is a vanilla interest rate swap. And every trade has a trade ID. In this case, the ID is swap_20Y, but that could be any sort of alphanumeric value that your company or you would want to use to identify unique trade IDs. The next subnode to actually describe that trade, we have a trade type. In this case, the trade type is swap, and that's a pretty broad category that represents many different types of instruments, from fixed floating IRS, interest rate swaps, cross-currency swaps, basically any exchange of regular or zero coupon flows from you to the counterparty or vice versa. With any number of leg combinations, you'd be using a swap trade type. And these trade types are listed explicitly in our XML specification. So you pick from a discrete list of those trade types when you're describing the trades in your portfolio. The next subnode here is the envelope, which is basically a collection of identifying information for your trade. So in most cases, you'll have your counterparty information, maybe a counterparty name and a netting set ID at a bare minimum. Maybe include some other things like your own party ID, so you can create a unique own party to counterparty pair, as well as potentially a valuation date, which would tell the pricing engine which market data to go and fetch to apply to that trade, so you can get accurate pricing or risk details at that valuation date. There's a bevy of additional optional information that you could include within this envelope, and that point brings me to the difference between a required field and an optional field. So for most of the walkthrough today, I'll be describing required fields, or essentially the bare minimum that would be required to represent that trade type within ORE XML. There are a large number of optional fields that you could include but are not necessary, that would help distinguish specific components of that trade from other trades, or change the trade type just slightly to represent unique circumstances of that trade. The interesting pieces here for the swap trade type, here now within the swap data node, our third subnode within this trade, it contains various leg data. So this trade, a simple vanilla interest rate swap, would be a fixed leg versus a floating leg. And you can see those two legs, and I'm just minimizing nodes here so you can see the sort of overall hierarchy of this trade. Those two legs are designated within this swap data node here. So if I expand here the fixed leg, I can see that there's a leg type designation and a payer flag here. a true-false designation. So a false designation here on this payer flag would mean that you're receiving this fixed flow, and that fixed flow is determined then by the rest of the information under leg data. So you're designating a currency, in this case, a single constant notional amount, certain conventions that would apply to this payment. So a day counter and a payment convention were a date to fall on a holiday or weekend. So in this case, MF would stand for modified following payment convention. Since this leg is a fixed rate leg, you would need to specify what that rate actually is in decimal form here. This looks to be just a single 2.1% fixed rate. However, within this rates subnode here, you do have the ability to specify multiple different rates, or there to be a step up or step down feature in that rate. Same thing here up in the notionals node. If there were any sort of amortizing or accreting feature to this notional, you could specify either explicit notional amounts here with various subnodes of notional, or, and I can get into this earlier, a little bit later, sorry, a rules-based application for amortization features of that notional. And then lastly, I touched on this a bit earlier, the schedule data node, which tells the pricing engine how to actually build the payment schedule. In this case, you would specify a start date, end date, and tenor or frequency. So in this case, it would be annual payments over a 20-year period. And you'd also need to specify some other assumptions like which calendar to use. Target is generally the European calendar. Alternatively, you could use a US calendar or London calendar. Any various global calendars are available. And then similarly, some other convention assumptions for building out that calendar. If I were to then move on to the second leg here, the floating leg, you'll see very similar structure where you have a leg type, a payer flag, and again, your currencies, notional amount, some convention assumptions. Here, floating leg data, though, is a bit different than the previous fixed leg data we saw before. In this case, you specify a floating rate index, and this here, Euribor-6M, is being specified from our allowable values for that floating rate index. So generally, floating rate indices will follow the form currency, rate, and tenor. So in this case, there's no floating rate spread applied, and this fixing is in advance, designated here by this is in arrears true-false flag, and the fixing gap, or number of days backwards from the previous period end date that we would go to fetch that fixing, is determined as 2 days. These are pretty common assumptions, though the XML standard does allow for flexibility in those assumptions. And again, here, the schedule data node is used and a rule-based schedule is being applied. Similar start and end dates. In this case, though, this leg is a semi-annual payment frequency denoted by 6M within the tenor. So just as I had earlier walked through sort of the explicit designation of notionals or rates with multiple notionals or multiple rates, if that were to occur. Alternatively, and I can get into this a bit later in the scheduled data section, you could specify individual rates here explicitly without having to go through a rules-based specification. So if it were to be a 0 coupon schedule, for example, it would just be a start date and an end date where those 2 dates are specified explicitly. If it was quarterly payments over a 2-year period, in that case, 9 dates would be specified: a start date, all your intermediate dates, and the end date. So here, I think it would also be useful to just walk through what a few other swap products would look like. So another common swap product outside of the interest rate realm is equity swaps. So here, the same general envelope a little bit less information than the previous trade. For example, no valuation date. But we do see the exact same form of swap data with two legs beneath. So in this case, there's a floating interest rate leg here. Since that payer flag is false, I know that I'm receiving this floating leg and paying the equity return. So in this case, again, very similar format to this floating leg that we just reviewed. Within this notional tab, we do see a couple new optional fields specified here, that there is no initial or notional exchange. Those are explicitly specified as false. Otherwise, everything else form-wise looks nearly identical to the previous floating rate leg of the interest rate swap. The new component here is the equity leg. In this case, we're paying the equity return. And everything else that you would see on the floating rate side is fairly similar, except for this equity leg data node here, where floating leg data would have been previously. So in this case, rather than specifying a floating rate index, you're specifying an equity ticker and the type of return that you're paying. So in this case, it would be a total return versus a price-only return, which would exclude dividends. Otherwise, structurally, very, very similar to the previous interest rate swap example that we just saw. Another common swap product here, a bond swap, a bond total return swap, or bondtrs. Again, a similar envelope information. I'll minimize that so we can focus exclusively on the bondtrs data. Similar to the equity swap, instead of specifying a equity, you're specifying here bond through the bond data, and that bond is identified through this ISIN and bond notional amount. We need a little bit more total return data here for the bond. In this case, we also need an initial price, the price type, so clean or dirty, whether that includes accrued interest. And then for schedule data on that bond side, we know that we are paying this bond return. And in this case, the schedule data that we're using is, as I mentioned before, specified explicitly as just two dates, a start date and an end date. So it's just being paid over essentially a 3-month period. And then on the funding data side, we know that it's a fixed leg funding. And because that payer leg is false, we know that we're receiving this, this fixed leg funding amount. The last swap product I want to walk you through is a credit default swap. So again, this would look fairly similar to the bondtrs example that we just walked through. However, in this case, it's a credit default swap. So instead of paying or receiving a bond return, you're paying or receiving an amount determined through a credit default event. So in this case, you would need to identify what that underlying credit reference entity is. In this case, you would do that through a series of issuer ID or credit curve ID. So in this case, where the credit default swap is referencing a Tesla default, and we know that we'll be either paying or receiving upon default through the funding leg amount here, or funding leg payer flag within the leg data node. So in this case, since we're paying a fixed fee for this credit protection, we know that we're buying protection on this Tesla entity. And the premium terms are determined here within this fixed leg data. So we're paying 1% per annum on this notional amount for that credit protection. And the various elements of that credit protection are determined here above within the credit default swap data. So things like whether the default settles, or whether the accrual settles at default, whether the payment occurs at default, the protection start date, whether there are any sort of upfront fees and the upfront date on which that fee would be paid are specified here in these subnodes to credit default swap data. Otherwise, the leg data here for the fixed premium leg is generally very, very similar to the fixed leg that we would have seen previously in the other examples. So another common trade type that we see on the vanilla side are forwards, and forwards are a bit simpler to represent than the previous example swaps. In this case, for an FX forward, the trade type is determined here, FX forward. Again, very similar identifying information, but here the forward data is quite simple actually. You have a forward valuation date, the date on which those cash flows would settle, and you have in this case for the FX forward, a bought currency and a sold currency, and associated bought amounts and sold amounts. So those two could be combined to determine your forward strike price, for example, for that forward exchange. And then lastly here, a required field, a settlement flag for cash settlement or physical settlement. Otherwise, that's a pretty simple representation for an FX forward. Because the open source risk engine is really only concerned about T0, so today's pricing or today's risk. In this case, we wouldn't even need to know the date on which the effective date on which the trade was agreed. All we need to know is from now forward, the forward valuation date. Similarly here for an equity forward, we have a long short designation, so a little bit dissimilar to the previous example for FX forward where we explicitly determine a bought currency and a sold currency. For the FX forward, here we have a flag to determine whether we are long or short the equity. We have a maturity, so very similar in the previous example to FX forward for the value date, the forward maturity. I know this is an old example because this forward maturity is actually in the past, but if this was a realistic trade, this would be at some point in the future. We have an equity ISIN, a currency for that equity, and then a strike price and a quantity for the number of shares that I would have traded forward. So again, similar in concept to the previous forward example, but we'll need to collect a little bit different information here for the equity forward as compared to the FX forward. The next example, or a handful of examples I want to walk through are vanilla options. So in this case, the vanilla equity option will look very similar to some of the information that we would have seen previously in the equity forward, but the key difference here is this option data node. So here, this node would tell you whether you're long, short the option type, so whether that option is a call or a put, for example, the style, so European being the most common, but also allowing for other styles like Bermudan or American options, and the settlement of that option, whether that settlement is cash or physical. And then, of course, the exercise date of the option. Otherwise, some of the information like the strike or the quantity, the equity ticker, and the currency are very similar information to what we would need to collect previously to identify that equity. Similar to how the schedule data node for swaps is reused across multiple different trade types, this option data node is also reused quite frequently across different types of options. So the next example is an interest rate swaption, a European exercise swaption. So in this case, if I were to just minimize here the identifying information for the envelope, which we're already quite similar or familiar with, I can also minimize the various elements here under swaption data. So if we were to just go back and look at the vanilla interest rate swap example that we first looked at, right? It was swap data with two legs underneath, a fixed leg and a floating leg. For our European swaption, it's again very similar with one floating leg component here and one fixed leg component here, with the payment directions being determined by the payer flag. But now we've added an option data node to specify whether from your perspective you're long or short the option, the style of that option, and again some of the previous features that we described previously for the equity option, like the exercise date. We can also see here we've included information about the premium In this case, it's a forward premium. So that premium actually would impact the current valuation of the trade if we were to determine that swaption NPV today. Again, similar if we were to compare the index CDS option, which is the next example I have, to the previous credit default swap example. We can see if we were to minimize under the index credit default swap option data node here, that's a mouthful. We can see it's generally going to be your CDS information here with the reference entity information identified here, and then your premium leg, fixed leg data being defined here. Now with an option data component on top to tell you whether you're long or short that option, or where you can tell the XML whether you're long or short that option, and various sort of option features. So I hope that serves to demonstrate sort of the building blocks of your basic swaps, and then how you can add an option feature on top to create swaptions. I also wanted to just touch on some slightly exotic or less vanilla flavors of options and how they can look very similar to previous examples with some slight differences. So in this example, it's an equity digital option. So an option if in the money would pay out a fixed amount. So in this case, we see the option data here being almost identical to the previous examples that we saw before, where you have a long short option type all the way through a premium and premium payment date. Here, though, instead of, as in the vanilla European equity example where we just have a strike and a quantity, for this digital equity option, we would also need to know what the payoff amount and payoff currency would be, along with the strike and the quantity and the equity ticker. I also wanted to demonstrate what various sort of barrier options flavors look like for equities. So in this case, again, if I were to minimize some of these subnodes under a OneTouch equity option, we have previously the option data that we saw before. In this case, we added some new information around a barrier data where we would have to specify a barrier level and the type of hit that barrier would take to be in the money. So in this case, it would be an up and in barrier. For this OneTouch option, it would combine some features that we saw previously with the digital option, where it would be a payoff amount and payoff currency. And then in this case, we would also specify an equity index that would tell us or allow the pricing engine to actually look back in history at the history of where that equity would trade, and be able to recognize if that, from the trade's effective date, if that equity had already breached that barrier or not, and would be eligible for that, that payoff. And then lastly, pretty similar before, but this is a European barrier option. Again, fairly repetitive at this point, but you see option data, a barrier data, and then the identifying information about the quantity and strike of that underlying equity. So before we get into some of the allowable values, I wanted to just highlight some of those differences that I talked through before in the rules versus explicit date, or rules or explicit notional based changes. So in this trade here, we have, in this case, a cross-currency swap, where we see, again, two legs, the fixed leg and a floating leg. In this case, because it's cross-currency swap, we know those two legs are going to be in different currencies. However, here we have an initial notional specified, but in this case, the notional has an amortization feature. So we would see that notional for some initial period amortizing downwards by this specified amount at a monthly frequency. And then after a certain period of time, that amortization would change to actually start increasing again with some frequency at some period of time. So this is what I would call a rules-based amortization. Similarly, on the fixed side, we also see a rules-based amortization on the sterling leg. And again, that would just serve to demonstrate, instead, this client could have entered in notionals explicitly. So instead of, this trade is nearly 10 years with monthly frequency. So this client could have entered in almost 120 different notional amounts explicitly rather than using a rules-based amortization, or use the rules-based amortization. And similarly, on the schedule side, the client could do either option as well. We see most of our clients using a rules-based schedule, as you see here and as you would have seen previously, though there are examples where we see clients using explicit dates. So one example here that I've highlighted is a equity swap. Again, the envelope identifying information about that trade. The interesting piece here is within the equity leg. So we see that we're paying this equity return on this notional amount, and that payment schedule is specified with the rules-based schedule. But within the identification of the equity leg, along with that also comes a specification of an explicit valuation schedule. Now, this valuation schedule must have been specified explicitly in the term sheet, so we can't assume that there's a one-to-one valuation date with the payment schedule, which would have been assumed if this valuation schedule were not to be provided. So here, you're specifying a series of dates, and each of those dates would correspond to a series of payment dates that would be specified here under a rules-based assumption. Another example is for, in this case, we see another swap with two legs for this trade ID. And because this trade has a leg type of CPI, I know this is an inflation swap. And in fact, because there are only two dates specified here within schedule data, I know this is a zero coupon inflation swap where there's only payment occurring at the end of the period. In this case, a 10-year zero coupon inflation swap on US CPI. We didn't review inflation swaps much in detail, but fairly similar to equity swaps or bond swaps, where instead of collecting information about the bond or equity, we would collect CPI or inflation-specific information about that inflation index. So in this case, there's a little bit more detail required than just a normal floating interest rate. But again, the concept of having two legs within swap data, in this case a CPI leg and a zero coupon fixed leg, is fairly similar. So to wrap up, the last thing I wanted to do was review allowable values for standard trade data. So within our XML specification, we do restrict the type of input information that you could include in the ORE XML file. So I would encourage you to retrieve the most recent ORE XML specification from the opensourcerisk.org website, or if you're using the Open-Source Risk Engine through one of our commercial providers, retrieve it directly from them. So in this case, our XML specification would show you the allowable values for various input fields like date or currency or role convention that you need to use when populating ORE XML. Similarly, allowable values for various calendars globally, certain day count event conventions that we saw previously, and certain floating rate indices which need to follow that form, currency, index, and tenor that I specified previously. So there's a whole lot of different restrictions that are applied based on the input information, but all of that can be found in the ORE XML specification. So again, I would encourage you to visit ORE XML opensourcerisk.org, excuse me, /XML for additional information about the input standard. And to reach out to info@quaternion.com if you had any questions about more exotic trades or want to inquire about information related to our commercial services. So again, my name is Scott Sobolewski, and I'd like to thank you for taking the time to listen to this introduction and to keep a lookout for other videos in this series that would serve to explain other introductory aspects of the open source risk engine. Have a great day.